So mine has a cute title. It's a little unusual. I'm using sensor data today. Probably should have done some image stuff. Maybe we'll show that depending on how much time we have. I mentioned later how we integrate, but there's a lot of different data that you could do with vector databases, with AI, with unstructured data. This one is just something I've been playing around with recently, so it's kind of fun to me. The slides I'm showing are available, so you could just grab them pretty quickly, and I'll put them in the chat so everybody can get all the stuff, so you don't have to try to take a photo or try to write stuff down. It'll all be there. I'm the developer advocate, one of them for Zilliz on the East Coast. I'm in New York. I'm doing events and meetups, and we have a meetup coming this month, and someone from people you know may be speaking there. There's a pretty good setup there. Now, I am not afraid to do demos because fortunately, Milvus is very solid, so it really doesn't crash. So, especially for the one that's cloud hosted, you could also run it in a notebook. You run it in Docker, run it in Kubernetes, can run it pretty much anywhere. But we have readily available demos running publicly, so you could try them out. And I posted those links so you could, give it a try, which is fun. I uploaded a picture of me in one of my Halloween decorations here, and it gave us back some interesting results. And it's me with a giant skeleton cat, and you may see some cat pictures and other stuff, but you could just pick any picture that's interesting to you that you might have, and then see if it could find something, like text to give you text, nice little example. This one, I uploaded a picture of one of my cats next to my computer. This is a multimodal image search demo, and I have some text in there saying what I want, and I did the search on it. And then, as you can see, it's in a different order. So we use a re-ranking algorithm to get those sorted a little better, which is pretty cool based on attributes from both of these items. So that is a cool feature that we have there, and you can see there, cats with the computers, white cat. Pretty cool, just to show you stuff works, it's running. We'll show you a more in-depth demo around air quality in a little bit, but I wanted to show you not just slides, see that this stuff works, and it's pretty cool that you could take unstructured data, whether it's an image, video, audio, big chunks of text, some combination of them together. And as you might expect, there's a lot of this data out there, and there's a lot of cool stuff you could do with it. It just keeps getting more and more. This number just came out. I don't know why they said megabytes instead of gigabytes or terabytes or petabytes, but I guess this number sounded really cool, and I like that too. 100 trillion megabytes of wireless data last year. That's that's just for the wireless data. So as you can imagine, this is just getting more and more. I mean, who's not using a ton of data? All of us. A lot of it is unstructured. It's logs, it's images, it's all these things. You might want to use that data, whether it's for doing a query, using it for various algorithms, using it for RAG, which is a big one. Taking what knowledge you have, regardless of what format it's in, get it run through some deep learning models, get it into vectors, just a bunch of numbers, and then get it in a database so you could use it, query it, use it in applications, use it in pipelines. It's actually pretty straightforward. It's very complex. If we had to hand write that math, this would be a different story. But vector search is pretty cool. I mean, you can upload a picture, as you saw, and it searches. And it's not, going there looking at two images and comparing them. It's turning them into numbers and using a bunch of different options for algorithms on how to map them next to each other. So you get that smart semantics of When I said cat, I meant this kind of cat and not a big piece of machinery that's cat, or, Apple to eat and not an awesome computer. A lot of use cases that make use of vector databases. These all make sense to most people. Obviously, the LLMs and RAG is a really fun and common use case. That one works out really well. Recommender systems have been used for a while with vector databases. Just search in text. I mean, it's nice to be able to search all your emails and PDFs and documents, what have you, without having to, worry about you have to set up special things for it. Very easy. Again, for images, video, audio, all that kind of fun stuff. I mean, you could do that with just a library, and there's a ton of fast vector search libraries. In fact, we incorporate them in the system, but a database gives you more. I mean, the ability to filter the results, hybrid search, where we can look at multiple types of things together, like dense vectors and sparse vectors, and do full text search. Again, you want to be able to have your data stored and not lost. Again, having it durable, having data replicated, highly available, having advanced database features like you'd expect in a relational database with shards, being able to have aggregations, things backed up, being able to create data, delete it, index things, have multiple users of the same things going on at once, having a lot of people query, lots of inserts happening, have things work with all the latest hardware as new and cool hardware comes out, especially GPUs. We do a lot of work with NVIDIA on that. So you really can't have billions of vectors, which when you start thinking of all the data that you can have in a database, it gets to be billions really fast once you start putting in logs and chat and emails and PDF. There's just so much cool stuff you can put in there. And then me throwing sensor data in there along with discussions on sensor data, all of a sudden you have a massive amount of data, and being able to search it and search it smart and quickly is really cool. And we'll show you some examples. Again, pretty easy to do this. The heavy lifting is handled by all the libraries underneath, fortunately, and by these different models we use to do our embeddings. That is kind of the secret sauce in the vector database, is having all these options for embedding models. As there's so many in the open source, there's so many from OpenAI and Cohere, and just so many different AI companies out there producing more and more models. Some of them you may need a key for. Some are freely available in HuggingFace or through PyTorch or through some other mechanism. Makes it very easy and flexible on how this data is stored, and then makes it available for different types of searching, different sizes. Again, lots of different applications can do them. Yeah, you might see a couple of cat pictures here, but to Milvus, it's all vectors. It's just numbers. It's just a matrix on the other side. Why Milvus first? There is a couple other databases out there, but being designed to run in the cloud, even though we can run in just a notebook or in Docker or something small, but designed to scale out as we had separate compute and storage, like a real distributed system, manage everything with Kubernetes, or let the Zilliz do it for you. Everything's designed for developing whatever you want to use. Most people do Python, but the Java libraries, Golang, JavaScript, C#, REST libraries are very strong. I spoke at the .NET conference very recently. We're tied in with all of our friends there, like Voxel 51, but obviously all the vendors of AI systems. LangChain works really well. I'll show you that one today. HuggingFace is great for models. I love those guys. And you run where you want to run. You run on your laptop, you run in a small cluster, small machine, run in industrial superpowered cloud. up to you. As many indexing types as you can want, depending on what you need. If you have a bunch of really good NVIDIA GPUs, the category one is pretty amazing. The performance and actually the cost is actually less. We had a talk about this with the engineer from NVIDIA, and it's actually, even though you're paying for the GPUs, the performance benefits you gain will save you money. So very cool there. And other options, so many options for how you index your data, what type of metrics are supported, and all the things you expect from a database, being able to upsert, getting range searches, being able to search by fields that aren't vectors, support for multiple vectors, being able to do change data capture, migrate your data around, having things that are tunable, multiple people can use them, lots of ways to search them, makes it pretty easy. And again, we're very well integrated with our friends here. So that makes for some interesting things you could do. And we'll have to show you a demo of that sometime because it is pretty awesome. It is good to work together. And let's show some real data here. So I am grabbing data from air quality around the United States. This is publicly available REST endpoint that is updated pretty frequently and gives you, some interesting data out there. It comes through a REST endpoint and you're getting chunks of 1,000 at a time. So I wrote a little Python app, grab this data, insert it into Milvus. 99% of this code is just to read it from the REST endpoint, format it a little, and then put it into Milvus. We just have an insert here. We put it into our collection, and we just have a bunch of fields here. The only magic sauce or something that's different from inserting into a regular database is down the bottom. We build a vector from one of the fields, and that just does a call to a function to do this for you. Makes it a little bit easier. And I will show you that in a live notebook. Hopefully nothing crashes on my end. Every time you're like, oh, let's do a live demo. Well, we'll see what happens. And then from there, I get that data into Milvus. Once it's inserted into Milvus, which can continuously happen, I can do a retrieval augmented generation application. Again, using LangChain, it's super easy. Same with Llama Index and a lot of other tools out there. Very easy to use Milvus as part of your RAG thing to get back good answers. Get the right context. And like mentioned in the first talk, help get rid of hallucinations. So you get back results that make sense. You don't want to let the model just improvise on the fly. I'm also running Ollama locally on my laptop. So this is a no-cost application. Everything's open source. Everything's running easily. And I can run Milvus wherever I need to. So if you want to just put this on a beefy laptop somewhere and run on its own, outside of grabbing data from the internet, you don't need to do anything. And if you just kept the old data you had, you wouldn't even need internet access to run this. Again, making demos a little safer. So we use LangChain to do our RAG. Very simple, which is impressive how little code you need to do. This is all the code other than some imports. We connect to Milvus, pick the collection name, pick the embedding function, tell LangChain what the primary field is, what my text field is, and get a connection to Milvus. Then we have a loop where we're going to run Ollama, which is running on my laptop, using Llama 3.1, pretty good model there. Set up a query so I could type in my notebook, connect to my vector store. I'm limiting this to parameter. I can change that, not change that. That's another option in the when I'm doing the retrieval, just to make it a little more focused. And then I post it out to a Slack channel just as a way to output it, not just to the notebook. show you some other things you could do. Pretty straightforward. Before we do question and answers, let's actually run this. So the secret sauce is actually injecting new data into the system. So I have a Python script that I'm running here in the command line. Probably better to run this with Spark or with Ray or maybe Flink or NiFi or Airbyte or Fivetran. Lots of different ways to run this. I can run this in Cloudera machine learning. Lots of ways to run scripts. Probably inserting your data from the command line. Probably not the most advanced way to do that, but that's one option. This is just this Python script, just so we can get data in. This is all I have to do to get embedding. This is a HuggingFace sentence transformer. I picked this one. This one is always available. Pretty performant, works pretty well with text. Only needs a CPU. If I had a GPU that's a little more powerful, I could do that. Don't really need it for a smaller model here. I'm going to grab some air quality, connect to Slack, connect to Milvus. This time I'm using Zilliz Cloud for my storage because my Docker died on me. It did an update and then something got invalid. Again, the demo god. So I switched over by changing one line in my code to point to a cloud and just use the collection there. Again, doesn't really matter other than if I put a lot of data somewhere and then I decide to move it, I'm going to have less data. But as you see, we're inserting data pretty quickly, so we get a lot of it in there. So not too much of a big deal. So I set up my collection, pick the schema. We could have dynamic fields if you want. So you could change the schema on the fly. Probably not the best idea, but if your data changes a lot, you could do it. I put in a number of scalar fields. These are just standard fields, like I've got text field for location. This could be metadata. This could be other things you want to filter on. The important thing here is having a vector. I could have up to 10, in the future more in one single row. And that might be because I might have a text one, I might have a couple of images, and they could be related, up to you. I set an index for that vector. If it hasn't been created, I create it, check to see if it's loaded. And now I'm going to call my rest thing 100 times with incrementing numbers because I'm going to give you back 1,000 records at a pop. And I want to put a decent number in there. So we do that, pass in the key, format my data. Here is I'm building a little piece of text here based on the results of the air quality. Append this into a format that I like, insert that into Milvus, and we're ready to go. And we could do things like search. Now that I've created this data, we can search and see, okay, which ones have a location that contains the uppercase letter H, and I'm also passing in an example vector to search on, which is vectorized there, just so you could, if I want to do something like pass in, this is cooler for images where I upload an image like you saw, vectorize that and use that as my search. Here, I'm just using, just a random thing to query on, but I could vectorize any kind of query pretty easy. Should we define schema for all collection create? Milvus doesn't have an auto collection creator based on looking at it. Again, because the most important data is usually not a whole bunch of fields. And we leave that to the tool vendors, things like Apache NiFi and Fivetran and some of the other tools are really good for ingesting that data. This is just example Python script just to make it easy and no cost for you injecting data. Now, if we pick dynamic schema, then you don't have to define the schema other than a dynamic field. and whatever your vector is. Remember, this is a vector database. I want to have a vector. Now, I don't need all those extra fields. I could just, if there was one field came back and it was a PDF, I could just vectorize that and put it in there and just have an ID and a vector. But I like to have metadata so I can get extra fields back that make sense to me or use them for filtering. Like here, we're filtering on, we're doing a group by on location. Again, different ways to get data back based on what's in there. Here, based on I want locations starting with a B, use this parameter. I could do whatever ones. Doesn't make whatever makes sense to you. We could get counts back. Again, we're at 300,000, so things are loading. Pretty straightforward. But again, you're not here just to search for your data. You might want to do a RAG-based query. And that's what I have here, an interactive one running in this notebook. I've run it a couple times already as we're loading new data, so we might get new results here. And that's just coming back. That's printing it to the screen. And when it's done, it's just going to send it to a Slack channel that I have set up for this. And if you're interested, you can join my free Slack group and get automatic posts as they show up. If you're interested in the air quality report for Trenton, which is near me here, it gives you some results here based on the most recent data. Plus, as part of the RAG, the Llama 3.1 is pretty smart. So it adds some extra stuff that isn't in my data that it knows from knowledge of air quality and some of the EPA guidelines. So it added this bit of helpful information, what good air quality is. The parts are pretty low today, though we're getting a little close, but pretty cool way to interact with your air quality data. And again, the amount of code to do a RAG app that's using Ollama running locally, LangChain and Milvus, pretty minimal. Again, I'm using the cloud version. The difference here, if you wanted to run the Milvus Lite one, which runs in the notebook, is you just change this URI. You don't have to do anything else. You would drop this token because if you're running locally, you don't have security, but pretty easy to do. That data is sitting in my free collections within Milvus, as they let you have a bunch of free ones. And you can see very easy to write different types of queries, do things like see all the fields, add new indexes, do different types of vector searches. Like here, if I want stuff that's like this row, I could use that to search by, and it'll give me back similar ones. Rank them, give me a similarity score. There happens to be a lot of them in this location in Houston, really pumps out the air quality data a lot. That's just what they do. What's cool with the Zilliz Cloud, it lets you test out different APIs here. So if you wanted to try out some of the REST endpoints, very easy to do. We also have a free tool to interact with your data. It's called @2, and it lets you point to wherever your Milvus database is and wherever your different fields are. Shows you, lets you create indexes if you want to add more. Shows you how much data you have. Lets you do interactive queries here, so I could add filters, add more of them. And then, which is pretty nice. Same for vector search. Vector search is cool because it'll produce code for me. So if I'm doing something special here, like I've come up with a good query I like, this is a nice way to get started. And I could just literally copy the Python code in here and then just drop it in a notebook and pretty much be ready to go as long as I have the same field names here. Like I got my collection name already in there. Well, that's the same one. And I could use, my connection. I have a different name. I don't like to use the word client because some other libraries use that as well. And that might be problematic. So literally paste that in there, make sure I have a real vector, and I should be able to run this query. Oh, they don't output anything, which would be boring. So we can output it, and you can see that query worked, just grabbing it from the tool. Pretty simple to do. All this code is published in GitHub, which I linked in there. And I have a little article on this in Medium that goes through a little bit of how to build this. I see we have some questions. We'll probably get to those now. I don't want to spend all the time in the world here running the same queries while I'm loading a lot of data here. Let's see, let's get to the question and answers. And if you have any more questions, now is a good time to do it. Let me go through the chat and the questions here. Tim's notebook code. Yes, you will get that. That's in the GitHub. That is linked everywhere. Let me paste that in there again, just so you have it. So I don't forget there. Pretty straightforward again. One to load, one to do queries, one to have a little interactive Q&A on the data, which is fun. Let's see here. How is a vector search different from KNN? Like, aren't you just vectoring data then finding the most similar vector? Yeah, that's most of the cases. There's a lot of different ways to do that. There is many algorithms, and we use a bunch of them. So yeah, we sit on those same libraries. That's the most common use case. That's the most common way you're doing the search. There is some other stuff in there that's more advanced when you're doing a hybrid search, when you're searching on multiple vectors, when you're filtering, when you're doing a sparse index versus a dense index. Everything starts out simple, and then you keep adding additional features so you can do cooler stuff. But there's a lot of things there. But yeah, that's the most common thing. Just it's the nearest neighbor is the main similarity there. There's not many alternatives there. What else do we have? Should we define a schema for all? Oh yeah, we said that about data ingest. Yeah, I mean, most people don't have, like I have here, this many fields. I mean, for me, I like it because I have that particular sensor data. Most people are ingesting something like, say, Medium data. I'm grabbing an article from Medium, so I'm not going to have a ton of fields. And those are just metadata that you might want to filter on. Like, if I'm loading hundreds of Medium articles from a dozen different authors, I might want to limit by author, limit by the blog, limit by certain tags. And again, adding those filtering makes things a lot faster. Why search on things that don't matter? We do this complex similarity search, but I don't want ones where the author is, say, Tim. I don't want Tim's articles. Make sure you don't return any of those. Well, I can filter those out, and then we're not wasting time searching all those. Just speeds things up. Nice to have, and nice to have that extra data, because I might want to join that to another data source. I mean, as part of a pipeline or an agent flow, I may want data from other sources. Having this data to be able to look up, like, that's why I often, especially for something that has it, if I've got a latitude and longitude, I am definitely making that a scalar field. So when someone retrieves, especially an agent, they can use that in the next part of their flow. Like, if next step could be, let me get weather. Let me get, if you've seen some of the other articles, let me get local traffic cameras based on that lat long. And now I could do a lot of things based on locality. So that is a nice thing to be able to look up and not parse. Where do I need to start to build my own AI tool? I mean, what's an AI tool? Do you mean your own model? Do you mean a tool? I mean, technically, this is a tool to search, to search air quality in different regions, and I can make this a Slack bot or a Discord bot, or make a website for searching this. That's an AI tool. If you want to do things starting off locally and on the free is nice, with a Jupyter notebook running locally, Ollama running on your machine, Milvus running on your machine with either Milvus Lite or with Docker. Very simple. Do you think this can be used for signing something like finding clips where a certain person is present? Definitely. You can definitely find video, audio, text, searching for a certain person. Now, if I'm going to build something like this, I'm going to purposely add extra fields in there so that I make it easier, because certainly having AI magic is great, but using things that we know for certain is even better. So if I'm going to, I was showing you the one with Medium. If I'm going to search for a person and I want to find their articles too, I'm definitely going to match it up to the field where it matches their name. I mean, it's just logical. So if I have a video, maybe it'll say who it's from, maybe not, but it could definitely find it in a picture. If I put an exact picture up and it looks like me, it's going to have a better chance of finding me in images and videos. That is a nice feature we have, but it's definitely something you could do. But I would improve your results because you're still relying on matching up using these algorithms. And some of the AI ones are better. You got to pick the model that matches what you're trying to do best, but giving it extra information. Like if I'm searching that for Milvus, if I did one that's multimodal, I want to put in some text here. So, if I have scalar fields or other information in there, like if I have a text along with this two vectors, I want to be able to narrow things down. Again, give me better results. Because, yeah, I could probably find someone, especially if it's unique, but having those extra fields to make it exact, why wouldn't you have that? What's the size limit? Oh, what did I run? I did the 8 billion, which is not small, but, small enough that it's not hurting my laptop here. Yeah, I've got, if you could look in here, you could see I'm using 3.1. I think by default, you pick the 8. Actually, can I list that? No, that's still right. Let's see. I go to Ollama. Yeah, I'm running, took 4.7 gig. I probably should get rid of the old one. I didn't get rid of that one yet. But yeah, that's the 8 billion parameters. Only 4.7 gig, but that's enough storage space used for that.